Dear students and future civil servants, welcome to the first class of Transform CSAT 2025. In today's class, the topic that we will be taking is clock. There is a specific reason why I am starting that class with this topic. Clock is such a topic which happens to be both important as well as easy. It is a low-hanging fruit. It is important because more or less every year a question has been asked on this topic, and in the year 2024, 2 questions were asked on this topic, and both of them, they were more or less very direct questions. And it is easy because the number of concepts that are there in this topic, they are limited. So that is why this is both easy and important, and that is why I call it a low-hanging fruit. So we shall begin the class now. Before beginning the class, I need to tell you 2 assumptions that we need to make before going to solving the questions. The first assumption is that whenever we are solving a problem of clock, we talk about analog clock. It is not a digital clock. It is an analog clock. You know the clock on your wall, which has a dial with numbers 1 to 12. That is the clock that we will be talking here. And the other assumption is it will be a sweeping clock. What is a sweeping clock? A sweeping clock is it is one which moves like this. Look at the seconds here. Look at the second hand here. It is moving slowly. It is moving slowly, smoothly. It is not making tick, tick, tick. So if it is making tick, 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 it is not a sweeping clock. This, look at the second hand and look at the minute hand. They are moving slowly and smoothly. So we will assume that whenever we are solving a problem on clock topic, the clock would be an analog clock and it would be a sweeping clock. So these 2 assumptions we need to have. And we need to learn one basic concept before starting the problems. The concept is angle. This angle, geometrical angle. Non-mathematical students, do not get afraid. This is a very easy concept. I will teach you the concept in less than a minute, and that should be enough to solve the questions on clock. Okay. An angle is defined as the space between 2 straight lines meeting at a point. So if there are 2 straight lines and they happen to meet at one point, the angle made between them, the space between them, it is said to be the angle made by them. For example, this is an angle, this is an angle, and this is an angle. Even though all the 3 in all the 3 pictures, the length of the straight lines, they are different, and even though the area between them, they happen to be different, the angle is same. That is the concept of angle. So if you can make out, if you can understand the concept of space, that is the angle. Okay. So angle is the space between 2 straight lines meeting at a point. Further, look at this diagram. Here 2 straight lines AO and OB, they are meeting here, and they are making a perfect L shape. This, it is called a right angle. This when they make a perfect perfect L shape, we call it a right angle, and it is said to be 90 degree. Angle, it is measured in degrees. Angle is measured in degrees, and when 2 lines they make a perfect L shape, the angle between them, it is said to be 90 degree. Now let us move this OB like this. Done. This is AO and this is OB. Now the angle between them is 180 degree. Why is it 180 degree? Because if the line were here, this would be 90 and this would be 90. So completely it is 180. Okay. And let us move this OB further to here, this way. Oh, we moved it like this. Now the angle that is made here is 270 degree. Why? Because from here to here it is 180 plus 90. So 180 plus 90, that would be 270 degree. And if you move OB further like this, if you do complete circle, that would be 360 degree, because 270 plus 90, that would be 360 degree. So when you make a complete circle, the angle that is made is 360 degree. This is all you need to know about angle to solve the questions on clocks. It was easy, right? Okay, now we are ready to answer the questions on clocks, and I have divided this class into 5 plus 1, that is 6 parts based on the concepts. So there are totally 5 concepts here to learn in clock, and 6th concept is a different one. I will teach you. Now we will begin with part 1. In part 1, we will talk about the speed of the hands. What are the hands of a clock? The minute hand and the hour hand, they are called the hands of a clock. usually 99% of the times we will not talk about the second hand. Whenever they tell you the hands of a clock, they mean hour hand and minute hand. So in part 1, we will talk about the speed of the hour hand and the minute hand. Okay, let us see the first question. I will teach you the concepts through questions, so that is easy to learn. Okay, it is a basic question. What is the angle traced by the minute hand in an hour? So what is the angle traced by minute hand in an hour? Okay, let us see. Let us say the time is 1 o'clock now. When the time is 1 o'clock, we are talking about minute hand, right? Okay, when the time is exactly 1 o'clock, the minute hand would be pointing exactly upward at 12. So there are 12 numbers. So minute hand would be pointing exactly upward at 12. Then after 1 hour, that is at 2 o'clock, the minute hand, it would make a full circle, and then again it would be back to showing at 12. So we know that a full circle, it is called, it is said to be, it is measured how much? It is measured 360 degree. So what is the angle traced by the minute hand in an hour? That is 360 degree. Then now based on this concept, we shall answer this question now. What is the speed of the minute hand in a clock? Now we shall derive this. It is very easy. We shall derive this. What is the speed of the minute hand in a clock? Using this concept, we can derive this one. I will tell you how. Now, we know that the minute hand, it makes 360 degree in how much time? In 1 hour. It makes, the minute hand, it makes 360 degree in 1 hour. Now, look at the options. All of them, they happen to be in minutes. So, we will convert this hour into minute. How? 1 hour is 360 minutes, right? That's all. So 360 divided by 60 minutes. This is the speed of the minute hand. 0, 0 cancel. And 6 divides 36. 6 6 are 36. So the answer is 6 degree per minute. So what is the speed of the minute hand? It is 6 degree per minute. And also make a note of this. It is a constant that we might want to make use in the future. The speed of the minute hand is how much? 6 degree per minute. Just make a note of it and memorize it. What is the speed of a minute hand? It is 6 degree per minute. Okay, let us go to an application level based on this concept. What is the angle traced by the minute hand of an analog clock between 4:04 and 4:44? So how do we answer this one? Okay, they are saying that there is a clock and it is analog. Even though they had not told us that they had not told us that it was analog, we would still assume that it is analog clock. Okay. Now, what is the angle traced by the minute hand of a clock between 4:04 and 4:44? So what they are asking us is, at the first instance, the time is 4:04. So the hour hand is showing 4 and the minute hand is showing 4 minutes. And at the second instance, the minute hand has come up to 4:44. Okay. Now, so what is the angle traced by? So what is the movement? What is the angle movement made by the minute hand? How do we solve this one? It is very simple. From 4:04 to 4:44, how many minutes have passed? It is easy, right? 40 minutes have passed. From 4:04 to 4:44, 40 minutes have passed. And we know that for every 1 minute, minute hand moves 6 degree, because that is the speed of the minute hand. Speed of the minute hand is 6 degree per minute. So for every 1 minute, it will move 6 degree. So for 40 minutes, how much will it move? It will move 40 minutes into 6 degree. That is how much? 4 6s are 24, add a 0, 240 degree. So from 4:04 to 4:44, the minute hand will move how much? 240 degree. Do we have an option? Yes, option C. Okay, now let us go to another sub-concept. This is a basic question. What is the angle traced by the hour hand in 12 hours? Okay, now they are talking about hour hand here. Hour hand. Okay, now how do we consider this? Consider 12 o'clock exactly in the noon, 12 p.m. in the noon. Okay. When the time is 12 p.m. Noon, the hour hand, it would be pointing again upward exactly at 12. Then when will it make a full circle again? It will make a full circle. When it makes a full circle, it will be 12 a.m. That is midnight. Again 12. So in 12 hours, that is from noon 12 to midnight 12, it will make a complete circle. And we know that a complete circle is 360 degree. So what is the angle traced by the hour hand in 12 hours? The answer is 360 degree. Okay. Now based on this concept, we shall answer this question. What is the speed of the hour hand in a clock? Okay. Now we shall find out this one just the same way we found out the speed of the minute hand. How? Now we know that hour hand makes 360 degree in how much time? In 12 hours. Okay. Here we have hour, but here all the options are minutes. So we will convert hour into minutes. So this would be 360 degree divided by 12 hours. How do we convert 12 hours into minutes? 12 into 60 minutes. 12 into 60 minutes. Okay. And this is our answer. Let us just simplify. 0, 0 cancel. And 6 divides 36. 6 6s are 36. And 6 divides 12. 6 1s are 6 and 6 2s are 12. So we have 1 by 2. So the speed of the hour hand is half degree per minute. So what is the value of half? The decimal value of half is 0.5 degree per minute. Okay. So what is the speed of an hour hand in a clock? It is 0.5 degree per minute. Once again, make a note of this and memorize this. The speed of a minute clock is 6 degree per minute and the speed of a hour hand is 0.5 degree per minute. Now based on this concept, we shall look at an application level question. Rani left the library at 8:22 p.m. While she was at the library studying, the hour hand of the library clock traced an angle of 33 degree. What was that time when she walked into the library? Now let us make sense of the question first. First, this girl called Rani, she walked into the library. Okay. And we do not know what was the time when she walked in. However, she sat and studied there for some time. And for the duration that she studied there, she sat and studied there, the hour hand made an angle of 33 degree. And then she got up and left the library at 8:22 p.m. So now using this clue that the hour hand made 33 degree angle, we need to find out at what time she entered the library. So how do we do this one? It is not so tough. I will show you how. Now they are talking about hour hand, right? So they are talking about hour hand. And what is the speed of the hour hand? It is half degree per minute. So it means that for every 1 minute, the hour hand will make half degree angle. Correct? Yes. So however minutes it takes, half of that degree angle it will make. For example, for 10 minutes, how much degree angle will it make? It will make 5 degree because 10 minutes, 10 into half, that is 5 degree. For 20 minutes, how much angle it will make? 20 into half, that is 10 degree. For 30 minutes, how much angle it will make? 30 into half, that is 15 degree. So that way, whatever be the minute number be, half of that will be the degree angle that is made by the hour hand. So for 60 minutes, that way, it will make 30 degree angle. So to make 33 degree angle, how much minutes are required? For 30 degree, we need 60 minutes. For 33, we need just double of that, right? So that means 66 minutes. So if you give it a time of 66 minutes, the hour hand will make an angle of 33 degree. It means that Rani sat and studied there for 66 minutes. Now, she left the library at 8:22. So she walked in 66 minutes before 8:22, and that is what we need to find. What we'll do is 8:22 minus 66 minutes. This is what we will do. So how to do this subtraction? It is simple. 8:22, 60 minutes before 8:22, it was 7:22, right? Because 60 minutes is 1 hour. So this is equal to 7:22 minus 6 minutes. Yes, because 60 minutes ago it was 7:22. Now 7:22 minus 6. Now do 22 minus 6. That is 16. 22 minus 6 is 16. So 66 minutes before 8:22, the time was 7:16, and that is the time when she entered the library. So the answer is 7:16 p.m. Done. This is the concept of speed of the hour hand and minute hand. Now we are done with part 1. Okay. Now we will begin with part 2. In part 2, we will talk about angle between the hands. Now, in the concept of speed of the hands, we talked about what is the angle made by each hand. How much angle hour hand makes and how much angle minute hand makes. Now we will talk about the angle between them. Let me clarify with the first question, then you will understand it better. What is the angle between the minute hand and the hour hand when the clock shows HM hours? For example, it might be anything. Let's take 12 o'clock, but 6 o'clock for example. When the time is 6 o'clock, this is how the clock will be showing, right? The hour hand will be pointing here and the minute hand will be pointing here. So what is the angle between them? It is 180 degree. So this is what we are finding out here. Angle between the hour hand and the minute hand. In the previous part 1, we talked about the angle made by either hour hand or the minute hand. Now we are talking about the angle between the hands of the clock. Okay. Now there is a ready available method to find out the angle between hour hand and minute hand at any given time. Take this HM as a formula. Whatever the time be, H is to M, that is at 6 o'clock H would be 6 and M would be 0, because how do you write 6 o'clock? 600, right? Yes. At 3 o'clock H would be 3 and M would be 0. At 12:15 H would be 12 and M would be 15. That way H is to M, that is H hours and M minutes. Okay. Now the question asks us, whenever the time is HM, what is the angle between the hour hand and the minute hand? And there is as I told you, there is a ready method for that. Just multiply the H with 30 and multiply M with 11/2. So you will get 30H and 11/2 M. Yes, you will get these two. And whichever of these two it is bigger, subtract it from the smaller. Sometimes 30H will be bigger and sometimes 11/2 M will be bigger. Just take the difference between the, if this is bigger, subtract this from this. If this is bigger, subtract this from this. And we can find out actually which one is bigger. When the hour hand is ahead of the minute hand, what is the ahead? For example, take 4:15. When the time is 4:15, the hour hand will be pointing at 4, but the minute hand will be pointing at 3. So the hour hand is ahead of the minute hand. In such an instance, when the hour hand is ahead, 30H will be greater than 11/2 M. So because hour is ahead, so 30H will be, H belongs to hour, right? So 30H will be greater than 11/2 M. And when the minute hand is ahead of the hour hand, for example, 4:30. When the time is 4:30, hour hand will be pointing 4, further than 4, and minute hand it will be pointing at 6. So minute hand is actually ahead of hour hand. So at that time, 11/2 M, it will be greater than 30H. Okay, just know this, but to find the angle between the hour hand and the minute hand, just follow this method. Multiply H with 30 and M with 11/2 and take the difference between them, and that will give you the angle between the hour hand and the minute hand at any given time. And there is one more thing to remember here, that the thing is, if the difference between them, it is less than 180 degree, keep it as it is. That is the angle. However, if it is more than 180 degree, subtract it from 360 degree. Okay. Just take notes of this. Just take notes of this. You will understand it better once we solve the upcoming problems. Now, make a note of this. Pause the video and take a note of this. Done. Okay. Now I will go to problem solving. The first problem. This was the question asked in 2024 paper, and I told you this is a very direct question. What is the angle between the minute hand and the hour hand when the clock shows 4:25 hours? So how do we solve this one? Simple, same method. Multiply the hour number with 30 and multiply the minute number with 11/2. What is 4 into 30? That is 120. What is 25 into 11/2? Do the math. It will be 137.5. It will come up to 120 and it will come up to 137.5. What is the difference between them? 120 and 137. This is bigger. If you subtract, you get 17.5. Is 17.5 less than 180? Yes, it is less than 180. So that is the required angle. If it were more than 180, we should have subtracted it from 360, but it is less than 180. So we'll keep it as it is, and the answer is 17.5 degree. So simple. Done. Now let us go to the next question. What is the angle between the minute hand and the hour hand when the clock shows 12:30 hours? Okay. Same way, same method. We will multiply the hour number with 30 and the minute number with 11/2. What is 12 into 30? It is 360. What is 30 into 15? It is 15 into 11. That would be 165. Now, what is the difference between them? The difference between them would be 195. Now, is it less than 180 or greater than 180? It is greater than 180. So, when this is greater than 180, what we need to do? You subtract it from 195. What is 360 minus 195? It is 165. And do we have an option? Yes, 165 degrees is the answer. Done. Now, based on this concept, we shall see some advanced questions now. When the hour and minute hands of a clock are coinciding, what will be the angle between them? What is this coinciding? Coinciding means overlapping. For example, 12 o'clock. What do the hour hand and the minute hand point when the time is 12 o'clock? Both of them, they will be pointing exactly upward when time is 12 o'clock. Hour hand will be pointing at 12 and the minute hand, it will also be pointing at 12. So, they are overlapping. Such overlapping, it is called as coinciding. Then what is the angle between them? The angle is 0 because they are completely together, one upon another. There is no angle between them. The angle is 0 degree. So, your answer is 0 degree. This was a basic question. Now, based on this concept, we shall answer this one. At what approximate time between 3 o'clock and 4 o'clock will the hour hand and the minute hand of a clock be coinciding? Now, this coinciding phenomenon, it is not exclusively to 12 o'clock alone. It actually happens multiple times. It happens multiple times throughout the clock. So, it also happens between 3 o'clock and 4 o'clock also. That is why in the beginning of the class, I told you that we imagine a sweeping analog clock. A sweeping clock. We imagine a sweeping clock where the minute hand and the hour hand and the second, they are all moving smoothly without any tick-tick, without any jerking. So, between 3 o'clock and 4 o'clock, some exact time, they will be overlapping. So, how do we find? There is a method to find this. How it is, between 3 and 4, the hour number it will always be 3. Look at the options, all of them are 3. Now, we need to find at what exact minute they will be overlapping. They will be overlapping. And here we learned that when they are overlapping or when they are coinciding, the angle will be 0 degree. So, using this concept and the method that we learned to find out the angle between the hour hand and the minute hand, we will solve this question. How? It is like this. Let us assume that when they are overlapping, the time is 3 m. M is minutes. 3 hours, m minutes, the hour hand and the minute hand, they will be overlapping. They will be coinciding. Now, how do you find the angle between them? Follow the same method. The angle between them, you would multiply with 30 and you would multiply with 11/2. So, you will get 90 and 11/2 m. Now, the difference between them, 90 and 11/2, it should be 0 degree, right? Why? Because they are coinciding. And we already know that when the hour hand and the minute hand are coinciding, the angle between them would be 0. So, if you take the difference between them, it has to be 0. We will do that. 90 minus 11/2 m, this would be 0. Just solve this equation for m and you will have the answer. 90 is equal to 11/2 m and 90 into 2 divided by 11 is equal to m, which would be 180 divided by 11. 11 ones are 11 and you have 70. 11 6 are 66 and the remainder would be 4. So, you get 5. Okay, 16 5/11 minutes. So, 16 point something minutes. 16 point something minutes. So, the time would be how much when they are coinciding? It would be 3 hours and 16 point something minutes. Do we have an option? Yes, 3:16. And the question tells us approximate. So, at 3:16 plus some seconds, not exactly at 3:16, a few seconds after 3:16, the hour hand and the minute hand, they will be coinciding. Done. Now, let us go to a PYQ, a previous year question based on this concept. This question, it was asked in 2021 paper. At which one of the following times do the hour hand and the minute hand of the clock make an angle of 180 degree with each other? Okay. Now we need to look at the options and choose that option during which the angle between the minute hand and the hour hand, it will be 180 degree. Look at the options. It is 7. It is 7 to 7.5. It is exactly at 7.5 and 7.5 to 7.10. So they are all talking about 7 o'clock plus something. So to use the same method, the time must be 7 am, right? When that phenomenon happens, the time must be 7 am, and if we find out what the value of m, then we will get the answer. Now we need to use the method that we use for finding the angle between the hands. We will multiply with 30 and we will multiply this one with 11 by 2. What is 7 into 30? That would be 210. What is m into 11 by 2? That would be 11 by 2 m. Now the difference between them, it has to be how much? It has to be 180 degree. Why? Because they have told us that the angle between the hands is 180 degree. So 210 minus 11 by 2 m, this should be equal to 180. Correct? Now we will transfer m this side and take 180 this side. 210 minus 180, that is equal to 11 by 2 m. 210 minus 180, it is 30 is equal to 11 by 2 m. Solve for m. 30 into 2, that is 60, divided by 11 is equal to m. So m would be 5 by 11. So that is 5 point something. Correct? So the time would be 7 hours 5 plus minutes. Correct? Yes. So which option will we choose? 7.5 or between 7.5 and 7.10? It is option D, not option C. Because it is not 7.5 exactly, it is 7.5 plus, and they have not given us approximately, and they have told us between 7.5 and 7.10. 7.5 plus, it falls between this bracket, right? 7.5 and 7.10. So we will choose option D. Done. Now we will go to next question. At the time HM, if the minute hand is ahead of the hour hand, then 30h is less than 11 by 2m or 30h is greater than 11 by 2. We have already learned this. If the minute hand is ahead of the hour hand, because whichever is ahead, that will be greater. So now the minute hand is ahead. So this side 11 by 2 it will be greater. So we'll choose option A. If the hour hand was ahead, then 30h would be greater than 11 by 2. We already know this. We to find the angle, we would just take the difference. But to see which one is actually greater, we follow this method. If the minute hand is ahead, then the minute set, that is 11 by 2 m would be greater than 30h. If the hour hand is ahead, then 30h would be greater than 11 by 2 m. Okay. Now based on this, we will answer this question now. This is a basic concept. Based on this concept, we will answer this question now. Between 2 p.m. and 3 p.m., the minute hand of a clock will be ahead of the minute hand, hour hand by 60 degree at what time? Simple question, right? Between 2 p.m. and 3 p.m., the minute hand will be ahead of the hour hand. The difference would be 6 degree at what time? So we will use the same method. What method? We will assume the time to be 2 hours and m minutes, and to find the angle between them, we would multiply this with 30 and we would multiply this with 11 by 2. 2 into 30 is 60 and m into 11 by 2 is 11 by 2 m. However, see here, the minute hand is ahead. So 11 by 2 m is greater than 60. So we will not do 60 minus 11 by 2. We will do 11 by 2 m minus 60. It is equal to the angle between them. And what is the angle between them? The angle between them is 6 degree. So the angle between them is 6 degree. So the difference is 6. Now we will solve for m now. 11 by 2 m, it is equal to 6 plus 60, that would be 66. And m is equal to 2 into 66 divided by 11. 11 divided 66, right? 11 6 are 66. 2 into 6, that would be 12. So if m is 12, then this time is how much? It is 2:12. So our answer is how much? It is 2:12. Option D. Done. Based on this, we will look at a previous year question now. No. Before going to the previous year question, you need to learn one more concept. From the perspective of the minute hand, 1 minute is equal to how much degree? So what is this? Now this is a method by which you will convert minutes into degrees. I will tell you how. What is the speed of the minute hand? The speed of the minute hand is 6 degree, right? So for every 1 minute, it will make an angle of 6 degree. That's it. That is the answer. For 1 minute, from the perspective of the minute hand, 1 minute is same as 6 degree. There is no distinction for it. The same way, for 2 minute, it will consider 2 minute to be 12 degree. For 3 minute, it will consider 3 minute to be 18 degree. Done. So from the perspective of the minute hand, 1 minute it is equal to 6 degree. Our answer is option A. Done. Now based on this concept, the previous 3 concepts that we learned, we'll answer a previous year question. This question, it was asked in the 2015 paper. Between 6 p.m. and 7 p.m., the minute hand of a clock will be ahead of the hour hand by 3 minutes at. So now between 6 p.m. and 7 p.m. at some time, exact time, the minute hand, it will be ahead of the hour hand by some degree. But they have given those degrees in terms of minutes. First, we will convert these minutes in terms of degrees, and then we will solve. Now we know that 3 minutes is equal to how many degrees? We learnt in the just previous problem that 1 minute is 6 degree, 2 minutes is 12 degree. So 3 minutes must be 18 degree. Done. Now the angle between them, it is 18 degree. Now we will take the time as 6 hours and m minutes. And how do we find the angle between them? Multiply this with 30 and multiply this with 11 by 2. 6 into 30, that is 180. M into 11 by 2, that is 11 by 2 m. Now which one of the hand is ahead? Minute hand is ahead, right? Minute hand is ahead. So we will do 11 by 2 minus 180, not 180 minus 11 by 2, because this one is ahead, this one will be more. Minute hand is ahead, so minute hand side will be more. 11 by 2 m minus 180, it is how much? It is 18 degree. So the angle between them is 18 degree. Now we will solve for m. 11 by 2 m is equal to 198. M is equal to 198 into 2 divided by 11. 11 divides 198. 11 ones are 11 and 11 eights are 88. So 18 by 2, it is 36. So m is equal to 36. It means that the time that we assumed 6m, it is nothing but 6:36. So at 6:36, the minute hand will be ahead of the hour hand by 18 degree or 3 minutes. So what is the answer? Answer is option C, 6:36. Now we are done with part 2. In part 3, we will talk about the relative positions of the hands. What do I mean by relative positions of the hands? There are 3 types of relative positions. The first one is coinciding. We already discussed that one. When hour hand and minute hand, they are one upon another. For example, 12 o'clock, they are said to be overlapping or coinciding. That is one relative position concept. The other is when the hour hand and the minute hand, they are pointing exactly opposite directions, or the angle between them is 180 degree. For example, 6 o'clock, when time is 6 o'clock, the hour hand, it will be pointing exactly downward, and the hour and the minute hand, it will be pointing exactly upward. This hour hand would be pointing at 6 and the minute hand, it would be pointing at 12, and they will be completely opposite directional. Then the angle between them is 180 degree. That we call as opposite directions. And the third one is right angle. UPSC has not still reached here. However, I expect UPSC to ask questions on this in the coming years, maybe this year or the next year. UPSC has been building one concept upon another every year by year. So it might ask a question on right angle this year or maybe next year. So when the hour hand and minute hand, they form a perfect L shape, or when the angle between them happens to be 90 degree, for example, 3 o'clock. When the time is 3 o'clock, the hour hand, it will be pointing at 3 and the minute hand, it will be pointing at 12. So then they form a perfect L shape. The angle between them is 90 degree. Or for another example is 9 o'clock. When the time is 9 o'clock, the hour hand, it would be pointing at 9 and the minute hand, it would be pointing at 12. Then also they will make a perfect L shape. Even though it is an inverted L or it is a twisted L, they form 90 degree. So such angle we call right angle. These 3 concepts we will learn now. When the hour hand and the minute hand, they will make how much? 0 degree or 180 degree or 90 degree between them. They will coincide, or they will be in opposite directions, or they will be at right angle. Now, no need to take this down. You shall take this one when I explain the concept further. First, we will talk about coinciding of the hour hand and minute hand. Pause the video and make a notes of it. The hour and minute hands are said to be coinciding or overlapping when they are positioned exactly one upon another. For example, 12 o'clock. Okay, this is only one instance and only one example. There are multiple such examples. 12 o'clock, it is an easy example to imagine. Okay, when the hour and minute hands are coinciding, they are pointing in the same direction and the angle between them is 0 degree. Correct. The hour and the minute hands will coincide 11 times in 12 hours. Make a note of this. How many times do they coincide? 11 times in 12 hours. So that is once every 720 by 11, that is equal to 65 5 by 11 minutes. It means to say that for every 65 point something minutes, they will make a coincidence. At 12 o'clock, they make coincidence, right? After 65 minutes after that, that is 1 5 something. From 12 o'clock to 1 5 something, it will be 65 minutes, right? 12 o'clock plus 60 minutes is 1 o'clock plus 5 minutes. So 1 o'clock, 5 minutes and some seconds, they will again coincide. Then after that, after 1 5, 2 o'clock, 10 minutes and something, they will again coincide. So this happens once every 65 point something minutes, and that way they will coincide exactly 11 times in 12 hours. There is no need to get confused. I will explain this further in detail. Look at these clocks. These are the exact 11 moments when the coincidence of the hour hand and minute hand happens. The 12 o'clock is the easiest to imagine. Here the time is 1 5 something, here it is 2 10 something, here it is 3 16 something, and here it is 4 22 something. And look at these times. I have made a list of it. When the time is 1 5, they coincide. When the time is 2 10, they coincide. When the time is 3 16, they coincide. When the time is 4 21, they coincide. The difference between these timings is 65 point something minutes. Here also the difference is 65 something minutes. Here also it is 65 minutes. Here also it is 65 minutes. That way, from here to here it is 65 minutes. And again after 12, again 1, there is also difference of 65 something minutes. There is no need to take this down. This is only for you to understand the concept. So just take a look. Pause the video and take a look when they will be coinciding. They will be coinciding 11 times. 11 times at exactly this time. Then there is no need to memorize this. I will tell you how to remember this. Okay, I am going to the next slide now. The overlapping or the coinciding, it happens between 1 o'clock and 2 o'clock. Now make a note of what I am saying. Yeah? Between 1 o'clock and 2 o'clock, they will overlap once. Between 2 o'clock and 3 o'clock, they will overlap once. Between 3 to 4, they will overlap once. So the general rule about coinciding is between any two exact hours. What is an exact hour? These are called exact hours. 1 o'clock, 2 o'clock, 3 o'clock. These are called exact hours. 3:15, it is not an exact hour. 4:22, it is not an exact hour. Where the minutes is 0, o'clock. When you say something o'clock, then that is an exact hour. Between any two exact hours, the minute hand and the hour hand, they will coincide once. Take it as a general rule. With an exception. What is the exception? What happens is, from 1 to 2, 2 to 3, that way, from 8 to 9, 9 to 10, 10 to 11, they coincide once, no problem. But 11 to 12, they will coincide once, and the time it happens to be 12 o'clock exactly. From 11 to 12, they coincide once, so that time would be 12 o'clock exactly. And between 12 o'clock to 1 o'clock, there also they coincide once, but the time is again 12 o'clock. So that 12 o'clock, it is common for both 11 to 12 and 12 to 1. So together from 11 to 1, they coincide only once. It is neither for this 11 to 12 or nor is it for 12 to 1. It belongs to both of them. From 1 to 2 once, yes. But from 11 to 1, the coincide happens only once, because 11 to 12 once, and that is 12 o'clock. From 12 to 1, that is also 1, and that is also 12 o'clock. So 12 o'clock, it is common for both of them, both the time durations, 11 to 12 and 12 to 1. So from 11 to 1, they coincide only once. So the general rule is that between any two consecutive exact hours, the minute hand and the hour hand, they coincide. With the exception is that from 11 to 1, they coincide only once, not twice. If you take any two, from 1 to 3, it is 2 times. From 2 to 4, it is 2 times. From 3 to 5, it is 2 times. But from 11 to 1, it is not 2 times, it is only 1 time. So take the general rule is between any two exact hours, they coincide once, with the exception that between 11 to 1, they will not coincide twice, but they will coincide only once. This is the general rule and this is the exception. Make a note of it. And okay, I will revise, I will come back to this once again. Now we are done with coinciding. Now we will talk about opposite directions. The hour hand and the minute hand are at opposite directions. The hour and minute hands are said to be in opposite directions when they are pointing in exactly opposite directions. For example, 6 o'clock. Look at this clock. It is showing 6 o'clock. The hour hand is pointing here and the minute hand is pointing here, and the angle between them is 180 degree, exactly opposite directions. So that is what we call by opposite directions. The angle between the hour hand and the minute hand will be 180 degree. The hour hand and the minute hand will be at opposite directions 11 times in 12 hours. The same rule applies for this one also. That is once every 720 by 11 or 65 point something minutes. I will tell you how to memorize this. No need to mugging up. No need of mugging up. I will tell you how to memorize this in the coming slides. So we learned this. Now we shall see the general rule and the exception for this one also. The general rule for this one is same as the previous one with the change in exception. From 1 o'clock to 2 o'clock, they will be in opposite direction once. From 2 to 3, they will in opposite direction once. From 3 to 4, they will be in opposite directions once. However, between 5 to 6, they will be in opposite direction once, but the time would be exactly 6 o'clock. And between 6 to 7, they will be in opposite directions once, but the time happens to be again 6 o'clock. So the 6 o'clock, it is common for both 5 to 6 duration and 6 to 7 duration. So from 5 to 7, they will not be in opposite directions 2 times, but only 1 time. So this is the exception. The general rule, take down the general rule. The general rule is that the hour hand and the minute hand, they will be at opposite directions between every 2 consecutive exact hours, with an exception that between 5 o'clock to 7 o'clock, they will be at opposite directions not 2 times but only 1 time. So that is the general rule and this is the exception. So because of this, what happens is instead of 12 times being at opposite directions, because of this one exception, they will be 11 times in opposite directions. The same applies for the coinciding or overlapping thing also. I told you they will be overlapping 11 times in 12 hours because of this, because of the exception. There the exception is 11 to 1. Here the exception is 5 to 7. Again, no need to mug up. I will tell you how to remember this. Okay. Now we talked about coinciding of the hour hand and minute hand, and we talked about the hour hand and minute hand, they being at opposite directions. Now we will talk about they being at right angle. Okay. Now the hour hand and the minute hand, they are said to be at right angle when they form a perfect L shape. For example, 3 o'clock or 9 o'clock. These are 2 are only examples. There are multiple such instances. The angle between the hour hand and the minute hand will be 90 degree. They will be at right angle once every 32 point something minutes. That is 360 by 11. And they will be at right angles 22 times in 12 hours. 22 times in 12 hours. Okay. Make a note of this. Then I will tell you how to visualize this. Okay. What happens is now I will tell you the general rule and the exception here. The general rule is that between every 2 exact hours, 1 to 2, 4 to 5, 5 to 6, 6 to 7, the hour hand and the minute hand, they will be at right angle 2 times. Between 1 to 2, they will be 2 times at right angle. Between 4 to 5, they will be 2 times at right angle. Between 5 to 6, they will be 2 times at right angle. The exception is that from 2 to 4 and from 8 to 10, they should be as per the general, they should be at right angle 4 times, right? No, they will be at right angle only 3 times. Okay. Because of this, instead of being for 12 hours, they should be, instead of being 24 times at right angle, they will be at right angle only 22 times, because here they lose one number and here they lose another number. So for 12 hours, they should have been at right angle 24 times, but because of this loss of 1 here and 1 here, they will be at, for every 12 hours, they will be at right angle 22 times. Then the general rule is that between every two exact hours, they will be at right angle 2 times, with the exception that between 2 to 4 and between 8 to 10, they will not be at right angle 4 times, but only 3 times. I will tell you why that one also in this slide. Here I am comparing all the 3 of them. I will repeat the general rule and the exception. Then you will understand it further. You will understand it better. About coinciding now, the general rule is between every 2 exact hours, that in 1 to 2 or 1 to 3, 2 to 3 or 3 to 4, the coinciding happens once. Between every 2 consecutive exact hours, the coinciding happens once, with the exception that from 11 to 1, the coinciding does not happen twice, but only once. Why? Because from 11 to 1, the coinciding happens at 12 o'clock exactly, and 12 o'clock it belongs to both 11 to 12 period and 12 to 1 period. So from 11 to 1, the coinciding does not, it is not to be counted twice, it is counted only once. Because of this, how many times do the coinciding happens in 12 hours? It is only 11 times. Because we lose one number here, so totally 11 times overlapping occurs. Done. And what is the frequency of this happening? It happens every 65 5 by 11 minutes. So 65 point something minutes. I will in one of the problems, upcoming problems, I will show you how to derive this one also. Okay. Just make a note of this one. If you want, you can write the entire table, or you can take just the general rule and the exception. The general rule is between every 2 exact hours, the overlapping happens once, with the exception that between 11 to 1, it does not happen 2 times, it happens only 1 time. So totally it will happen 11 times in 12 hours, and the time difference between every 2 times that it happens between 1 to 2, it happens at 1:05 rate. Between 2 to 3, it happens at 2:10. So the time difference between that instance and this instance, it would be 65 5 by 11 minutes. Now this is all about coinciding. Now we will talk about opposite directions. Now the hour end and the minute end, they will be at opposite directions. The general rule is that they will be at opposite directions between every 2 consecutive exact hours, once between every 2 exact hours, with the exception that between 5 to 7, they will not be at opposite directions 2 times, but only 1 time. Why? Because for the period 5 to 6 and 6 to 7, they will be at opposite directions exactly at 6. So 6 o'clock, it is both common to 5 to 6 and 6 to 7. Because of that, we cannot count it twice. 5 to 7, only 1 time is counted. And because of that exception, how many times do the hour end and the minute end be at opposite directions in 12 hours? That is 11 times for 12 hours. And what is the time difference between one time they being at opposite and this next time they being at opposite direction? It is same for this one and this one, 65 5 by 11 minutes. So for one time they are at opposite direction, and the next for the instance to remember, 65 minutes has to pass. For example, they will be at opposite directions at 6 o'clock. When will be they at opposite direction again? When the time is 7:05 something. Why? Because at 6 o'clock they are already at opposite direction. 65 minutes after that, that is 7:05 something, it will be 65 minutes. Or 65 minutes before 6 o'clock, the time would be 4:54 or 4:55. Then also they will be at opposite directions. So between any 2 instances of happening, the time difference would be same, 65 5 by 11 minutes or 65 point something minutes. This is the general rule and the exception and the interval of opposite directions. Now we talk about right angle. The general rule is that between every 2 consecutive exact hours, that is 1 to 2 or 4 to 5 or 5 to 6, the hour end and the minute end, they will be at right angle to each other 2 times, with the exception that between 2 to 4 and between 8 to 10, they will not be at right angle 4 times, but only 3 times. And now I will tell you why. Because in the 2 to 3 bracket, they will be at the right angle somewhere between, at one time they will be at right angle between 2 to 3, and at the second time they will be at right angle exactly at 3 o'clock. And between 3 to 4, first time they will be at right angle at exactly 3 o'clock, and then somewhere between 3 and 4. So 3 o'clock, it is common to both 2 and 4. From 2 to 3, somewhere between 2 and 3, they will be at right angle one time, and at 3 o'clock exactly they will be at right angle. Okay, so 3 o'clock is counted once. And from 3 to 4, at 3 o'clock they are at right angle, and after 3 to 4, somewhere in between 3 to 4, they will be at right angle. So 3 o'clock is common for 2 and 4. So we cannot count it twice. So between 2 to 4, they will be at right angle only 3 times and not 4 times. Similar way, because of 9 o'clock, from 8 to 9, they will be at right angle 2 times, and one time, one of them will be 9 o'clock. At exactly 9 o'clock, from between 8 to 9, they will be at right angle. And from 9 to 10, they will be at right angle at exactly 9 o'clock and somewhere between 9 and 10. So we cannot count 9 2 times. So from 8 to 10, they will be at right angle not 4 times, but only 3 times. Because of this, in any given 12 hours, they will be at right angle 22 times. Correct? And what is the time difference between one time they are at right angle and the next time they are right angle? It is a constant. It is 32 8 by 11 minutes. 32 point something minutes. Done. Now you will understand the general rule, the exception, and this time period and this time. You will understand much better when we solve the problems. Now we shall go to solving the problems. How many times do the hour hand and the minute hand coincide in 12 hours? We have a ready answer for this one. It is 11 times. Correct? We know because of this exception, how many times do the hour hand and the minute hand coincide? 11 times. Done. We shall go to the next question. How many times the hour hand and the minute hand coincide in a clock between 10 a.m. and 2 p.m. on the same day? This question, it was asked in the 24-year paper, and it is a direct question. Now, from 10 to 2, they want us to tell them how many times the hour hand and the minute hand will coincide. So we know right. From 10 to 11, they coincide once, and from 11 to 1, they coincide only once and not twice because of the exception. And then from 1 to 2, they coincide once. So totally, they coincide 3 times. Whenever they ask you the question, they will involve this exception. They will not ask the question without the exception rule. Whenever such a question comes, they will involve this exception rule. So from 10 to 2, they will coincide not 4 times, but 3 times. So the answer is 3 times. Okay. Now we'll go to the next question. How many times are the hour hand and the minute hand pointing in opposite directions in 12 hours? We have answer ready for that. It is 11 times. Why? Because of the exception rule. This exception rule. Even though the general rule says that between every 2 consecutive exact hours, they will be at opposite directions once, but from 5 to 7, they will be at opposite directions not 2 times, but only 1 time. So for 12 hours, how many times will they be at opposite directions? The answer is 11 times. Okay. Let us go to the next question. How many times will the hour hand and the minute hand minute hand of a clock be in opposite directions between 3 p.m. and 9 p.m. on the same day? It is 7. We just need to manually count it. From 3 to 9, right? From 3 to 4, 1 time. From 4 to 5, 1 time. And from 5 to 7, this is the exception. From 5 to 7, 1 time. 7 to 8, 1 time. And 8 to 9, 1 time. Totally 5 times. So from 3 to 9 on the same day, how many times will they be in opposite directions? The answer is 5 times. Okay. Let us go to the next question now. How many times are the hour hand and the minute hand at right angle to each other in 12 hours? We know that even though the general rule states that between every 2 consecutive exact hours, they happen to be at right angle 2 times. However, because of these 2 exceptions, where 3 and 3 instead of 4 and 4, they will be at right angle to each other 22 times in 24 hours. So the answer is 22 times. Done. Let us go to the next question now. How many times will the hour hand and the minute hand of a clock be at right angle to each other between 1 o'clock and 4 o'clock? Okay. We just need to manually count it. From 1 to 2, they will be at right angle 2 times. And from 2 to 4, they will be at right angle 3 times. This is an exception case. So totally from 1 to 4, they will be at right angle how many times? 5 times. The answer is 5 times. Okay. What is the time period between one instance when the hour hand and the minute hand are in opposite directions and the next instance the same happens? Now what they are asking us is, what is the time interval between 2 instances when they will be at opposite directions? We know that the answer is 65 5 by 11, but here we will see how to derive it. You need not memorize it, you can derive it actually. I will tell you how. So for 11 times, for them to be at opposite directions, they take how much time? They take 12 hours, right? For every 12 hours, they will be at opposite directions 11 times. Or in other words, they will take 11, for them to be at opposite directions 11 times, they take 12 hours. For one time for them to be at opposite directions, how much time will they take? They will take 12 by 11 hours. So this is the interval between every two such instances. So this is your answer, 12 by 11 hours. However, the options are in minutes. So we will convert this into minutes. So 1 hour is equal to 60 minutes, right? So 12 into 60 divided by 11 minutes. 12 6 are 72. So 720 by 11 minutes. And if you do the division, you will get 65 point something. Then, so the answer is 720 by 11 minutes. Once every how many minutes do the hour hand and the minute hand of a clock beat right angle to each other? Same way. So for them to be 22 times at right angle to each other, they take 12 hours, right? That is, for every 12 hours, they will be at right angle to each other 22 times. For one time for them to be at right angle, they will take how much time? They will take 12 by 22 hours. What is 12 by 22? That would be 6 by 11 hours. Now the options are in minutes. So we will convert hours into minutes. How? 6 into 60 divided by 11 minutes. That is 360 by 11 minutes. If you do the division, I think you will get 32 point something minutes. Okay. So the answer is 360 by 11. Do we have an option? Yes, 360 by 11 minutes. Okay. Now, based on these concepts, we will look at a previous year question. Assume that the hour hand and the minute hands of a clock are moving without jerking. Yes, we have already made that assumption. We have assumed that when it comes to clock, all the clocks are sweeping clocks. The clock shows the time between 8 o'clock and 9 o'clock. Okay. The two hands of the clock are one above another. So somewhere between 8 o'clock and 9 o'clock, the two hands of the clock, that is the hour hand and the minute hand, they are overlapping or coinciding. After how many minutes, nearest integer, that is approximately, will the two hands be again lying on one above another? So they are telling us that between 8 o'clock and 9 o'clock, they are coinciding. Then between 9 and 10, they will coincide again. What is the time period between those two instances? We already know the answer. It is 720 by 11. And if you do the calculation, it will come to 65 point something. We have already made the calculation in the previous problem. It is 720 by 11. However, we shall repeat it here. So for coincidence to happen, they how many times do they coincide in 12 hours? They coincide 11 times in 12 hours, right? They coincide 11 times in 12 hours because of the general rule and the exception. For one time for them to coincide, they will take how much time? They will take 12 by 11 hours. Now, we want the answer in minutes, right? So we will convert this into minutes. 12 into 60 divided by 11 minutes. What is 12 into 60? That would be 720 by 11. Now if we divide, 11 6s are 66 and you get the remainder 50 or 60. Then 11 5s are 55 and now we remain with 5 by 11. So 65 point something minutes. And that is our answer. So the nearest option is 65. Yes. Okay. Now this is about they being at opposite, coinciding or opposite directions or at right angle. Now, how many times do the minute hand and the second hand coincide in 60 minutes? Until now, we talked about hour hand and minute hand. Now look at second hand. This is very rare to be asked. It was asked only once in one of the previous year questions. However, we shall see. How many times do the minute hand and the second hand coincide in 60 minutes? The answer is 59 times and I will tell you how. Memorize this and take it as a general rule and exception. The rule is that between every 2 minutes, the hour does not matter. It can be 3-1 or 4-1 or 5-1, it does not matter. Between every 2 minutes, from 3-1 to 3-2, between 4-1 to 4-2, between 5-1 to 5-2, between 1 and 2, the hour hand it does not matter at all. Between 1 and 2, between 1 minute and 2 minutes, the minute hand and the second hand, they will coincide. Between 2 and 3, they will coincide once. Between 3 and 4, they will coincide once. Between 1 and 2 once, between 2 and 3 once, between 3 and 4 once, between 4 and 5 once. So, the general rule is that between every exact minutes, 3-1, 3-2, 3-3, the minute hand and the second hand, they will coincide once, with the exception that from 59th minute to first minute, they will not coincide twice, but they will coincide only once, because the exception occurs at exactly 60 minutes. From 359 to 360, they will coincide once, and that at that time, the time would be 360. And between 360 to 41, so that is the next hour. From 360 to 41, the minute hand and the second hand, they will coincide once, and that time would be 360 or 4 o'clock. Okay. So this 60th minute, it is common for both these periods, 59 to 60 and 60 to 1. Because of that, from 59th minute to first minute, they will not coincide twice, but only once. So that is the general rule, exception. Because of that exception, they will be at right angle to one another. So they will be coinciding, the minute hand and the second hand, they will be coinciding 59 times in every 60 minutes. Make a note of it. Okay. Now, based on these concepts that we learned, we will solve a previous year question. Consider the following statements. Between 316 and 317, both the hour hand and minute hand coincide. Okay, statement 1. Statement 2. Between 458 and 459, both the minute hand and the second hand coincide. Which of the above statements is or are correct? So, we shall evaluate both the statements one by one. Look at the first statement. It says that between 316 and 317, both the hour hand and the minute hand coincide. So, how do we calculate this? We calculate using the angle between the hour hand and the minute hand method. What we will do is, we know that between 3 o'clock and 4 o'clock, they coincide once. But using this method, we will find the exact time. And if the time happens to fall between 316 and 317, then statement 1 is correct. So, how do we find the angle between them? Multiply this with 30 and multiply this with 11 by 2. This would be 90 and this would be 11 by 2 m. So, when they are coinciding, the angle between them, they will be 0 degree, right? So, 90 minus 11 by 2 m, it is 0. So, 90 is equal to 11 by 2 m. M is equal to 90 into 2 divided by 11, or 180 divided by 11. So, 11 ones are 11, 11 6 are 66, and you have 4 remainder. So, at 316 point something minutes, the hour hand and the minute hand, they will coincide. So, does that time 316 something, does it fall between 316 and 317? Yes. So, statement 1 is correct. Now, let us look at statement 2. Between 458 and 459, both minute hand and second hand coincide. Now, they are talking about minute hand and second hand. And what does the rule say? The general rule says that between every two exact minutes, that is 58 and 59, the minute hand and the second hand, they coincide once, with the exception that from 59th minute to first minute, they coincide not twice but only once. But this falls under the general rule, 58 to 59, it falls under the general rule category. Yes, so between 458 and 459, the minute hand and the second hand, they coincide once. So, statement 2, it is also correct. And what is our answer? Our answer is both 1 and 2. Now, we are done with 3 parts of the problem topic. Now, we have 2 more parts to cover.